That's better. That should be okay. Yeah? Yep. Interesting, we got low battery on this one. See if it... I picked yours for the moment.
That's fine.
Okay. Oh, wow.
Pues, bueno, lo hago en inglés, ¿vale? Ahora va a ser en inglés. We're really lucky to have here Peter with us. Peter has been involved within the OSGi development for the last
16 years.
16 years. Okay, so
I guess some of you... okay, no, that's not that bad.
yeah, we're really lucky to have here with us.
Yeah.
So just enjoy the talk and thank you very much, Peter.
Yeah, go
for having
ahead.
here with us.
Yeah, tonight I'm hola, very happy to be here. It's very nice. Actually, my first visit ever to Madrid, which is I actually live not that far in Montpellier in France, so we're almost neighbors. Tonight, I was asked to give a talk, and currently my favorite talk is. Oh, let me first establish. Everybody speaks English fluently. I have a tendency to increase my speed a bit when I get enthusiastic, which happens quite often. So just yell at me and slow me down, because it's much better that the presentation takes a bit more time than that I've been wasting my time because people didn't understand what I was saying. And if you have a question about anything, just stop me. It's not that I learned this by heart and can not be interrupted. So please interrupt me. Yes, I'm the OSGi. Currently, I was the OSGi evangelist. I've been involved in the first technical work. I was first working for Ericsson. So I've been there for a very long time. And about 2 years ago, 3 years ago almost now, I started to get this feeling that I was becoming a consultant. Now, I had been officially a consultant for my whole working life. I started working for, well, I never really had a boss, so I always was independent and always been working for other people on a contract basis. But I've always been able to do the work with my hands in the gutter. I always wrote a lot of software. I always solved real problems. And in the OSGi work in the beginning, there was a lot of that involved. But over the years, I became one that could talk about it. And I could talk about it pretty well, but I started to feel so many things happening in the real world. And I just had the discussion before as well. I think there are two things about cognition, and that is you can understand something. After tonight, a lot of you people will understand what I talked about. I think everybody in this room, because otherwise you wouldn't be here. But there is a big difference between understanding something and feeling something. If, for example, before this 3 years ago, if you asked me any question about JavaScript, then I could answer you because I could talk about it. I read all the books and I had done some Hello World things, so I was an expert in JavaScript. But once you've been writing JavaScript for a real project and you solve real problems, then you feel JavaScript. So anyway, that was the reason that I had been working in the OSGi. I've been basically the editor for the specification. So if you read these thousands of pages of specs, then basically all of them has gone through my hands. And but I was feeling I was floating. And I wanted to go back to reality and build real systems again, because I think that's the most fun. So I took a year, or basically I said to the OSGi, sorry, I'm going to leave. Crying, big goodbye. And I'm going to do something myself. And what I did, I built a project, JPM. It's actually part of EnRoute, so we'll show you a little bit about it. It's a repository. It's like Maven Central. Actually, it scans Maven Central, but it's a user interface on top of it. So there was web stuff involved, all the CSS, the HTML. There was deployment involved because it runs on Amazon, so you had to figure out how to work in the cloud. So all these things, I don't say it was a huge system, but it was more than life size. It was not a toy application. Spent a year on it. And when I built that application, I because I did not leave OSGi because I thought it was the wrong technology. Absolutely not. I thought it was the best technology out there, the best solution out there. And I decided to build that JPM completely on OSGi. So, because my big frustration over the past 10 years, I think the enterprise people came into the OSGi around 2004, I think. So that's actually 10 years ago. Sky, but I from the beginning. There's a lot of static stuff in there. Build an object, how you create your instance, with what uncohesive APIs. Anyway, lots of than I expected. But what I also found out that there were a lot of missing pieces. The nice thing about Java Enterprise, like I also say nice things about Java Enterprise. The nice thing is that it is, there's a very small chance that if you get the whole enchilada, that you're actually going to miss the lettuce, because the lettuce is probably hidden somewhere in there. You get everything, even a lot of stuff that you don't need. If you go to OSGi, it's the completely opposite. You don't get nothing, and you have to pick the parts that build your application. The result, the end result is usually nicer because it only contains the things that you really need. And it also then only contains the bugs for the stuff that you really need. So you get simpler application, you get a simpler model. But what turned out, and in my case it wasn't a big problem because I love to write all that middleware and all these components. But I wrote a whole bunch of components that I really felt should be part of the ecosystem that is around OSGi, and they aren't. We got some specifications. About half of them are really very useful and they're really good and they're heavily used, but we're missing at least 20 or 30 services handling a persistent queue. We don't really have an API in OSGi for, so people have to go to the Java EE world and they drag in the whole static nightmare that is involved in it, and trying to make that mix between trying to create your objects through static class loading or to class loader and giving it class for name. And OSGi is nightmarish. It's really awful. If you're fully in the OSGi world and you live in instances only, everything is an instance, you never use statics, it's beautiful. But this bridging the old world and the new world is really hard. So what I did is I went to the OSGi Alliance, because after a year I actually started to feel I should talk to other people again. I had been really only talking to my computer. And I proposed to do a project where we tried to create a more or less open source kind of run project. Not specified, not all the guarantees that you get from the official OSGi specification, but try to make it really easy to use OSGi. Also solve the whole tool problem is, how do you get started? If you start with Ruby on Rails, you get a whole environment and you got your hello world in 5 minutes and the whole chain up and running. OSGi, it's a lot harder to get there. But all the stuff is there. So what I'm going to talk about, this was just the introduction, is this project that came out of it. Because I gave them a call and they said, oh, we'll talk about it in the board. And then during that call, can you join the call? And we talked about it, said, okay, we want to do this. So okay, then I'll start next month. Oh, could you start next week? So it was very nice to be back in the OSGi, and this is the project. Let's talk about it. Now, this is a project, it's a little bit like a very small open source project. Yeah, we got IBM, we got Oracle in the back, but that's not what you should expect here. This is currently, most of it is a single man's work, half-time, because they didn't hire me full-time. So there's a lot of loose ends. Don't expect a ready-made thing. But it is something that we're looking for people that say, yeah, this is where we want to go to. And through the OSGi, we can rally a lot of support also on the official side. What we want to do is a complete development chain for OSGi, that you can make enterprisey kind of application, like a Ruby on Rails kind of model, without having to go to the nightmare of picking all your components, making it all work together. Of course, we did the most important thing first. We designed the logo. These were the temporary designs, but in the end, this is the OSGi EnRoute logo. So now, just going back to all this, I just want to spend a little bit of time it's not some library that is the hit of today. It's really a way of thinking. It's a lifestyle. Because I think modularity is existing. And it's like a big problems that I see is that a lot of environment compared by language. There's a lot of blogs telling you how fantastic Go is. And there's an even larger amount of blogs that tells you what fantastic Ruby is. But I don't think that hello world, which often you see this comparison between environments, it's not a really good benchmark, because when you go to real applications, there's so much more than the language. Actually, normally you get thousands of languages in your application nowadays. And I think when we try to reach heaven before, we did a try, and languages were actually the problem, not the solution. So when I look at the whole landscape, I think language is not unimportant, because a language allows you to think in a certain way as well. But much more important actually is the whole development chain behind it. It's your build tools, it's how everything integrates, how your IDE works, how you, your efficiency, your productivity is to a very large extent what comes before and what comes after it. And actually when you look at that landscape, then overall, I'm trying to get IntelliJ in there as well for the people that are on that side. I think we got some odd team out there because it's not, the marketing is a little bit lacking and there's a lot of shininess missing. And anybody that's read my blog can knows that I wrote one actually about the uncoolness of Java, the unbearable uncoolness of Java. But Java, OSGi, Eclipse, find bugs for static analysis is actually very code, and you actually a lot of people, and where the discussion is usually about. We have this problem of small versus large. To get started to make your hello world. Let's face it, if you use Ruby or Python, hello world is basically quote, hello world, quote, and that's it. Smalltalk is even smaller. Smalltalk is my original language, so that will pop up more often, I think. So with dynamic languages, they're really cool. And when you go to universities, students love them because you can do all this shit that they want to do, and it's cool. Is cool still cool, or is cool not cool anymore? I don't know. So what happens with Java and OSGi? I'll wrap them together because I think actually they're the same thing to a very large extent. You'll see that if you want to get your hello world, oh gosh, I have to create a file, and I have to put package in there. What the hell is a package? And then a class. Why? And even if you got the class running, so that if you look at JavaScript, anybody doing JavaScript? If you look at JavaScript, then you see really this problem that they, oh, we want to do it easy and it should be simple, and they use short names in the beginning. And when you but when you get bigger systems, suddenly he also used foo, and she also used foo, and suddenly we get this really hard problem that somebody is spending a few days trying to figure out why it doesn't work because there was a clash in names. So actually it was a good reason to put that package statement in there because you were preparing for the future. So the big difference I see is that Java, and definitely with OSGi, we start much higher, but we don't really get into this hockey curve that quickly. So the startup cost of Java, which stepling type, is higher. I always run ahead of my own presentations. I should watch out what I'm doing. Long-term cost is lower than dynamic language. And actually you see that with Twitter. They started out with Ruby on Rails, I think, and they switched to Java because they found out that the maintenance cost was too high. And as I said, I was running ahead of myself. You got foo there, and you got foo there. It looks exactly the same. We learned virtually every error that you make. Eclipse, the place where the guy was defined, or we can rename it to bar, field that happened to be called foo as well. This OSGi thingy, why OSGi? What OSGi does to the Java, when we build large systems, it saves our ass many times. The problem is that Java was always designed to be a single namespace. When you look at Java, you got a foo.x, then there can only be one foo.x in the language, on the language level. In reality, when you build systems, they evolve over time, and you're going to have a foo.x today and a foo.x tomorrow that is slightly different. So the type safety system in Java doesn't extend to an evolving model. There's no versioning in there, and that's what OSGi provides. What OSGi provides is a module system. You got entities that have an inside and that have an outside. That evolve over time. And we make sure that all that type safety is carried over time. Our semantic versioning, everything is built around that all these goodies that you get from type safety, that they don't get lost there, and that happens. And I'd love to have a discussion. I always like it when people disagree with me. So the big problem that we normally run into is that when people start to do all the good stuff, they run into this brick wall. And quite a number of people actually don't give up and keep running into that brick wall or leave another area. Well, there's a perfectly good door out there to go in there. It's called the service model, because a lot of the problems that you find that people run into with OSGi are related to the fact they want to use the static model in J2E and other classic Java, which just doesn't mix very well with the OSGi more dynamic model. So we want to address that. And the way we want to address that is OSGi EnRoute. So what do we do there? In this project, we have this situation in the world. People want to start here because that's the shortcut. But over time, they really regret not being there. So what we want to do with EnRoute is actually push this boundary, not boundary, this line. We want to push it down, make it easy to get started with OSGi EnRoute, which means that we can compete easily with all those easy solutions. Now, little question, how many people actually did something with OSGi already? Read something about it? Maybe you should have prepared a slide about that. It allows you to package your two bundles deployed in runtime altogether. And we have capabilities. When you export a package, you have a capability of a package, and you have a requirement for the package. That's the importer, and the the framework binds those things together. That's all making sure that the classes that are linked together in the runtime are actually compatible with each other. We got versioning around that, huge amount of specifications to really make that work. Cool part is that you can actually have multiple versions of the same package at the same time in your system. You never want to have that. It's always ugly, but it's nice that you can that you actually can. And it's a lifesaver quite often. If you want to hear me rant about Maven, and this is one of those areas where Maven basically ignores this aspect that you have two different versions of the same package. One of the key aspects actually why OSGi works, this is just the basic boring stuff, but the cool stuff of OSGi is the service model. In the service model, when you go to a modular system and you get these requirements and capabilities, then what you find with Maven, where you get hard-coded references to other artifacts, you often find out that if you change something here, that you have to change it in a lot of other places. That like blocks with them and move them into another place. Now, modules will always be like that, but when you analyze that it collaborates with other guys, we need to talk about, you have configuration information and I want to get my configuration information from you. There's a collaboration going on, and you might have an event dispatching mechanism or a percentage on you, and that's a dynamic dependency because we want to be able to change you for somebody else, or there might be, I have a very interesting presentation and anybody that's interested can put up its hand and I want to send it to him. There's these primitives out there where you want to collaborate. I'm standing here in the front of a room of 30 people, and when you look at it, I might collaborate with 3 or 4 people. And if between the modules. And that's a dynamic process, and that looks very magical if you're not used to that. But once you get into OSGi, it becomes a primitive. I'm going to repeat the story I talked about half an hour ago. I'm old, I know, gray hair. I've been very busy in the 80s selling objects, just as enthusiastic, well, maybe even more enthusiastic as I'm talking here now. I've been doing this for a very, very, very long time. And when I talked about objects, I always got this reaction, especially from experienced people. They were sitting on the table, and then they said, okay, objects are really good. And then you see them leaning back a bit, oh yeah, why? And you talk, oh, well, you know, polymorphism is fantastic. Inheritance, we have function pointers, we do this with a function test, no problem, there's nothing special there. The key thing was that they understood the way objects work, but they didn't feel it. I'm pretty sure that anybody in this room, when I talk about polymorphism and I talk about inheritance and I talk about methods, and you don't even think twice about it, because it's not that you understand it, you feel it. When I give you a problem and there's some similarity, you think about interfaces or inheritance, how you model that. Now that's the same thing is that microservices, that's how we coined them, and unfortunately the term is being stolen right now for web services, unfortunately. But a microservice in OSGi is really the concept of one of those primitives. A microservice, if you have your config admin, you register an object that implements an interface. And I can actually ask for anybody that has that interface. Now it's not just the interface, because the contract is actually once you get a library, it's language actually. It's microservice, and what I hope to make clear is really a way of thinking, because they really use over time without having versions and tying everything together. You write a hello world and it downloads the internet. It's not fair, it's not Maven that downloads the internet, it's people that download the internet, because they have POMs that refer to other POMs that refer to other POMs that refer to other POMs. The other thing what we really are really strong at in OSGi is dependency model. We translated all the dependencies into a unified language, requirements, capabilities. OSGi EnRoute will take advantage of that in every place. And the whole idea is that you should never in runtime run into something, oh shit, somebody called me, but I don't have it. Well, you always have runtime resources, method not there, or class not there, or the certificate not there. Anything that you can express as a requirement, the static resolving will detect that. Might automatically drag it in, but your system starts and says, you should have full access to everything that's in Maven Central that you needed. The reuse is the biggest time saver, normally, not always. After you've done that, we create a run descriptor. The run descriptor has a distribution. The EnRoute project is going to provide an implementation for all the EnRoute profile specifications. So you don't have to worry. When you're going to start from scratch, it works. IBM promised for their Liberty profile on WebSphere that they'll provide a distribution for their stuff. Now, the interesting part here is the resolve part, because that is new. There's no other environment that I know that has this. Because if you start using OSGi or any other system where you have to start build things from scratch, you run into this problem that, oh, now I need X. Oh, got X. Now I need Y. And now I need this. And now I need, you get this. We use that resolver is a deployable unit jar, and it contains an OSGi framework system, an OSGi application subsystem. Out of it, because release it to the repository, so that it actually becomes available to other people. That's the development. Well, not got more. Oh yeah. Once it's in the repository, we can stage it to Q&A, and when they're happy with it, we go to production. So this is the, of course, everybody will have a different model, but this is the archetypical development model that EnRoute has at its base. This is where the tools are chosen from. So BND, talked a little bit about it. One big time waster for me has been actually BND, because part of my EnRoute work is that I maintain the BND tool. BND is used in Maven, BND tools, SBT, that's I think a Scala build tool. It's in Gradle, it is in anybody so far. Spring once had their own little tool called Bundler, but nowadays everybody that builds bundles uses BND to build the bundles. What does it do? The core thing does basically two different things. It takes a manifest, that's the metadata, It augments it, it analyzes it, and it puts all the jar and the classes, and it can manipulate. It's really good at manipulating jar files. And in the end, it creates a bundle that is a valid OSGi bundle. The metadata is verified, or you get errors, of course. It's a completely independent library. It has no dependencies, so that's why it's so easy to put it in other tools and use it in different places. It's got an API, but normally you use it with properties files that construct 99. That we got more and more projects, got different bundles. Actually, we're just using everything with N. Actually, I don't even say that here. There's a lot of stuff out there, but that was a big weak part of BND. It wasn't very well documented. Hi, Ray. He was whining, oh no, he was complaining about it, that he had to read the source code to understand certain parts. It's all open source. So this is the, so the core is the BND lib that you can put in anywhere. When we talk about workspace, I'm going to speed up a bit because otherwise we won't have enough time. Workspace, we have a CNF file in there that contains your shared configuration for a number of projects. So it's not that every project is completely standalone. The workspace is like a module, and you have a set of projects in there, and some of them are exported to the repository, some of them are purely local for testing and that kind of stuff. But CNF contains your configuration. Then you have a number of projects in there. Those are normally Eclipse projects when you're in Eclipse, and there will be IntelliJ thingies when they're IntelliJ. And we have a repository. Projects can export one or more bundles. Bundles go to the repository, and they can be imported by other projects in other workspaces. So again, it's modular all the way down, Bundles are modules, classes are modules, packages are modules, projects are modules, workspace is a module. And in the workspace, we export, import bundles, and we do that through a repository. So when we go to the profiles, very important to realize that they are absolutely pure. No implementation code. You can't run anything in there. Everything is about specification. It's only for compile. We have the microservices in there. We have something called extenders. One of the cool things in OSGi is that you do not, because you're guaranteed to get a callback when a new bundle is installed. You can actually go out there and say, oh, you get installed. For example, there's a framework is running, and you get installed in that framework and say, oh, wow, maybe it's got something that I'm interested in. So I take a look, and you might have a header, or you might have a resource in your jar. For example, you need a database. You might have some DDL code in there. And the moment you get installed, I look at your DDL, I compare whatever is in there with my current version of the database. Might migrate the database to see if the check is the new database. I'm not. So what is planned? Everything is based on Java 1.8. That usually creates some pain, but the jump to Java 8 is so big. I'm a small talker. Smalltalk had lambdas in 1972. You had no idea how painful it was to go to Java in 1996 and not have functions that you could pass around. So Java 1.8 is for me the minimum. And I think if you look at the time frame we're planning, then I think that is good enough for the moment. We want to make it so we should is patient stuff. It contains EVG one page, and then persistence, but there's a lot of political pressure to go to JPA, so it's not there yet. Have already been released. I think it's finalizing, or it's been released, so they're already out there. Compendium servers are going to be, won't go into all the details, that's on the website. Then let's take a look at the tool, BND tools. As I said, a workspace is a CNF directory. You can create a new project. We put out lots of recommendations on how you should use your naming, because if you get a large project, naming of projects and naming of workspaces is actually incredibly helpful if you do that consistently. So we'll describe how to do that. In BND tools there will be a template. we actually enforce some of the naming things. If you call something x.y.c.test, then we'll create a test project for you. If you call it .api, we create an API project. If you call it .provider, we create an implementation project. So there's some naming convention that will automatically, that's described here, pick up. So when we do that, we create basically the control. The bnd.bnd file is driving the building. Also in Maven, also in, well, you can use it in Maven. And we have different Maven solutions. For Eclipse, nothing in your home directory. Every detail is contained in this file. And Eclipse generates a container so that you have the right class path. You change it in the, it's a text file, and we keep Eclipse completely synchronized with that file. Or in end. So when we do the offline build, the continuous integration on Través, it will, or Jenkins, it will automatically build the identical same thing. Not almost identical. Actually, we do something called baselining, which really requires that we need to build the bitwise same thing in Eclipse as what we do in the continuous integration build, which is really good if you can do that. This is basically the service model, which is the core concept of how you build. If you build OSGi stuff, you're going to create services that are defined in a package. This is the symbol. This is the call direction and or the dependency direction. So this guy depends on that guy. He is registering a service. The pubs, we have evented everything. He is registering this. Are defined in components or object. One component depends on services. So your thinking model for a component is really, I'm using a few services and I can provide one or more services as well. And these services, because they are dynamic, they allow you to model a lot of things that in normal code really takes a lot of effort. And what we did, we made it really easy to use those dependencies, even though they're really complicated to do. From the point of view of the developer, it's as simple as putting an annotation on it. And in a way, it looks close to what is it, CDI nowadays, or Spring annotations. It's basically kind of an injection model. But what you should realize is it's not a one-time thing. What you create is a dynamic thing that has dependencies. And when these dependencies go away, your component must react. For example, we have a component, and we have a reference to a database. If that database is away, getting but that looks like a lot of bull anymore. It's one of those things like objects that once you're in your code and you say, I actually really would like to have a service here or depend on a service. You slam the component on it and you automatically get the activate called whenever your dependencies are met. And again, there's a lot of fine-tuning that you can you can make optional references. So there's a lot of whatever you want to do, you can do it. But the simple model is really you say, I depend on A, B, and C. Call me when all are there. And when any of them is gone, just call me that I'm gone and get killed again. Of course, I ran ahead of myself again. The deactivate components. See my own slides ahead of time. And so inside the bundle we find the components and they can be linked internally on the service level, but in the end you also export some services to other people. Plus any resources that you have there. So the bundle basically looks like a component again. It's a recursive structure or a fractal structure. You see that it depends on services. And again, this is a dynamic dependency. It's not that you have your static dependency, your packages, and your other requirements. But this is dynamic. These services can come and go, and the system will automatically. It's like you plan that you have enough resources. That's the static part. And then you schedule what you're actually going to have and what you want to provide. We can actually create multiple bundles in one project. Maven has this restriction that you can only create one jar file, and it has some advantages. In practice, you often find you've got some tests in the different. In the descriptor, you have private packages. The repository that will provide us that. I did in my. You can actually, when you look for the window, Eclipse, and delay in that I have to get rid of. Then you can jar file and we'll make it available to the dependencies in Maven terms. That will give you just one that's specific dependency. So once we're there, we're going to go back to the recursion. We're going to services. So we put the bundles together. They have, again, the services. And again, an OSGi framework can also export and import services. We have distributed OSGi that allows you to talk to services in another framework transparently. So this is the basic development model, how you would work. Distros, because I'm actually over time, almost over time. A distro is, because we made everything a specification on the compile side, we need somebody to provide us with the implementation. And that actually will register the services that we are going to depend on in runtime. One of the things I'm trying to do is get a complete open source project. I'm trying to use as much projects as are out there. I'm using Apache log servers, I'm gathering and testing as much as possible from open source as I can lay my hand on, because obviously I don't want to do it myself. However, there are a few things that currently are not in open source on the OSGi organization on GitHub. For the missing, I've got several ways I can get rid of it, leave it, which will be a lot easier when EnRoute is used by a lot of people. But for the there is some implementation that and there's some other stuff in there as well. Okay. Well, you know, that's the toy stuff. We're going to give you the real stuff that runs on WebSphere. I hope they will actually create a distribution for the profiles that runs on embedded, that runs really well on embedded. So how do we, with the capability model, we try to it's too much to really explain it in detail here, but the capability model here is basically, it says, capability is a set of properties. Capability is always in a namespace. For example, the package, then it would be in the OSGi package namespace. Additionally, every capability will have a set of properties. And the value of that property should be the name of the package. There's a version property, and the value of that should be the version of that package. So we create a little language, basically, a property key language for every namespace. Every namespace can have its own language. Then the second part of this thing is the requirement. What is a requirement? A requirement is a filter. OSGi, from day one, and I can honestly say that it's because of me that it's in there, because I fought for it and I won, in this case, has a very powerful language based on LDAP. LDAP, nobody knows it anymore, but in the old days, 90s, LDAP was supposed to be the big thing, so we took that over. And of course it did help that it was really easy to parse. You can write a parser, it's very structured, you don't need a complicated parser, a couple of hundred lines. The requirement says the capability expressions, for example, say I want to have package X, but a printer says that the first of those requirements, because those root requirements of my fractal model that I think is really, then methods are part of a class. They import and you have packages, you import packages, you edit the workspace where you import, export bundles through the repository there. So I kind of like the elegance of this fractal model of how you can those bundles with others, but you control that sharing. You do not just put it in a jar and hope somebody will use it or somebody will not use it. You actually are in charge of what you're sharing and how you're sharing it. So the overall model then is basically we have the development model around the workspace. We have these different components that you need when you do development, and we've got B&D tools for the IDE. And if you what's left, that pace meter, and that starts to hurt. Ask Ray. Adapted, and there's going to be a few other tutorials. The key thing is to develop in a way that's very modular, which means that in the production, and we use it in software, yeah, you can use them. And a lot of course they recognize it from their familiar and they go ahead. But there are some OSGi application. Declarative services is clever enough to see it in 1998. This is a so we learned a lot, and EnRoute is many more, less complexity, work left to get there, but we know how. It's got a very large code base here. It's not going to be easy. You're going to get lots of small. You know, in the next 7 years, we're going to write the same amount. 7 years? No. Just wait. The thing is, what I'm trying to say is that they did some studies about the software industry, and in the next 7 years, we will write the same lines of code as we've written in the past 14 billion years. And 7 years later, we'll double it again. So the thing is, we have to be a bit careful about the backward compatibility issues. That it's much easier to stay where you are because you know it, you got your head around it, you feel the solutions in your existing environment. And in OSGi is foreign. You will have to do a lot of learning. There will be a lot. I think the end result is significantly less complex, which allows you to grow with less cost and allows you to provide more. Yeah. And the beauty actually is that if you deploy it as bundles, in the bundles, and then you would create JavaScript code or Ruby. The box with my first goal talking to TTP server in there, and then I can make Angular. I actually think about it at Liferay. I do believe strongly that in the near future we will not use HTML on the server side anymore. Computer and Angular has the advantage. I want to go there. That's fine. There. So that's the goal. The even deploy D3 code. If I download of time, with OSGi we got it available at the right place. Significantly easier. And you don't swear.
You use OSGi. You can build applications, groups. There is this bundle to make the other bundles see the changes. Your bundle
that you don't want to deploy on a live system. I think that's if you can do that, then I'm go to any computer that is running the system. Get the version that we tested in and actually when they train fighter pilots, you know, jets, Mirages, to be dynamic. That's what OSGi. So it's fantastic during development. System, if your system, it's the same thing when I talk about fidelity. There's a lot of people themselves to the right environment. Anyway, thank you very much for listening, and hope you didn't fall asleep.